2 kilogram block is held in equilibrium on an incline of angle 60 degree. Okay, this is the theta 60 degree by a horizontal force F. So this is the horizontal force F in the direction shown in figure below. If the coefficient of static friction between block and incline is 0.3, this is the coefficient of friction. Determine the minimum value of F. Okay, minimum value of F to maintain the block in equilibrium, okay, at rest at that inclined plane, and then the normal force N of the inclined plane on the block. Okay, so first you have to draw all the forces acting on this block. Okay, so this block have weight, of course, direction downward, vertically downward, and then it has normal force 90 degree to the inclined plane. Okay, normal force, and then F. Okay, so we can transfer F to here. Okay, and then we can resolve W. Okay, we can resolve W to component which is parallel to the inclined plane and perpendicular to the inclined plane. Okay, so this is the W Y. Okay, parallel to the inclined plane, and then this is this is WX. Okay, WX. Okay, this one is WX, and then this is WY. And you also have to resolve F, okay, into component which is parallel to the inclined plane and perpendicular to the inclined plane. Okay, so theta is equivalent to here. Alright, so we can solve by looking at this dimension. Okay, this will be the X dimension, and this one will be the Y dimension. Okay, this one is X component, and the component which is parallel to the inclined plane is the X component, and the component which is perpendicular to the inclined plane is the Y component. Okay, so maybe we can draw free body diagram for this object. Okay, maybe I can use ruler here. Okay, so this is the inclined plane. Alright, okay, this is the inclined plane. Or maybe we don't have to draw this one. Okay, just draw the object. Okay, represent by a dot. Okay, represent by a dot, and then so this is weight, vertically downward, and then we have to resolve weight to X component and Y component, and then this is the normal 90 degree or perpendicular to the plane, and then this is the force F. Okay, This is the force F. Okay, so we can resolve F into component which is parallel to the inclined plane and perpendicular to the inclined plane, and theta is here and it is equivalent to here. Okay, so this is the y component. Okay, and then this is the x component. Okay, so it states that the block is in equilibrium. That means we may apply net force x equals to 0 and net force y equals to 0. Okay, so for net force x equals to 0, so we have fx and wx. Oh, we forgot one more force, okay, which is the friction. Okay, friction, because it gives you the coefficient of friction. That means this incline has frictional force. Okay, so the frictional force, it depends on the direction of the tendency of this object to move up the plane or down the plane. So we have this kind of push force. Okay, the force F push the block up the plane, so this block tends to move up the plane. Okay, so direction of motion might be up the plane. Okay, so frictional force will be down the plane. Okay, frictional force is down the plane. Okay, down the plane like this. So we have Wx friction and Fx at x component. Okay, so it become Fx plus negative friction. Okay, because it is opposite direction of motion, plus negative Wx equals to 0. Okay, so as you can see here, for Wx we can relate to the theta. Wx is W sin theta and Wy is W cos theta. And then for the Fx, okay, for the Fx, it is F cos theta and Fy is F sin theta. Okay, so we can substitute Fx. Okay, Fx is F cos 60 degree, and then friction is from the formula. Friction equals to coefficient times normal force. Okay, so minus mu is 0.3. It is given. Okay, mu is 0.3. Okay, and then times normal is unknown here, and Wx is W sin theta, where W is equals to mass times gravity. Okay, so we can substitute mass times gravity, sine 60 degree equals to 0. Alright, so mass of the block is 2 kilogram. Okay, mass of the block is 2 kilogram. Okay, maybe we can simplify, okay, this equation. cos 60 degree equals to 0.5. Okay, 0.5 f minus 0.3 n minus mass is 2 kilogram times g 9.81 sine 60 degree equals to 0. Okay, then we can proceed. Okay, so 0.5 f minus 0.3 n equals to 2 times 9.81 times sine 60 degree equals 16.99. So we have one equation with two unknown. Okay, so leave this equation okay first, and then we can proceed for component y. For component y, net force y equals to 0. So for component y, we have let me highlight this component. Okay, we have n fy and wy. Okay, so it become n plus negative fy because fy is downward plus negative wy. Okay, negative wy. Okay, negative wy because it is downward. Okay, so n minus fy, where fy is f sine 60 degree, and wy is w cos theta, w cos theta. Okay, w cos 60 degree equals to 0. Okay, then we can simplify. N minus f sine 60 degree. Sine 60 degree equals to 0.866. So this one become 0.866 f, and w equals to mg. Okay, m is 2 kilogram, g is 9.81. Cos 60 degree equals to 0. Okay, so maybe we can let n be the subject. So n equals to 0.866 f plus 2 times 9.81 times cos 60 equals 9.81. Okay, so we have equation 2 with two unknown. Okay, so maybe we can substitute equation 2 into equation 1. Okay, the rest is mathematics. Okay, so 0.5 f. Okay, this is equation 1 from equation 1 minus 0.3 n, where n is the normal force. Normal force is from the component y. Okay, we have 0.866 f plus 9.81 equals to 16.99. Okay, then we can simplify. 0.3 times 0.866. Okay. Okay, so we have 0.5 f minus 0.2598 f minus 2.943 equals to 16.99. So we can determine f. Okay, f equals to 82.99 Newton. Okay, and then how about the normal force? Okay, normal force maybe from equation 2. Okay, from equation 2, so N equals to 0.866 F, where F is 82.99. Okay, plus 9.81. So N equals 81.68 Newton. Okay, so we already calculate force and normal force.